Identify the name of the functional group in this formula. So our formula is CH3COCH3. It's very difficult to deduce which functional group it is by just looking at it. So let's draw the structural formula first, and we're going to be able to see which homologous series it is and ultimately which functional group it is. So we have a carbon that is bonded to 3 hydrogens, and after that we have a carbon that is bonded to another carbon and an oxygen. So we're expecting a double bond so that the carbon can have 4 bonds, and then the last carbon is bonded to 3 hydrogens. As you can see, we have a ketone, so is our answer C in 1.1? No, our answer is actually not C. The question is asking us to identify the name of the functional group. So even though this is a ketone, the answer is actually D, because the name of the functional group of ketones is carbonyl. So our answer is D for 1.1 and not C. 1.2. Which of the following is the empirical formula of 1.2-dichloroethane? In order to find the empirical formula, we need the molecular formula. So we have 1.2-dichloroethane. The structure will be something like this. So there we have our dichloro, and we have hydrogens elsewhere. This is 1.2-dichloroethane. We have 2 carbons, we have 4 hydrogens, and we have 2 chlorines. What we have to do now is to divide by the smallest number, and we're going to have our empirical formula. Our smallest number is 2, here and here. If we go ahead and do that, we're going to have CH2Cl. We divided every number by the smallest number. So which option is what we have here? That is option B. So our answer to 1.2 is actually B. 1.3. Consider the structural formula of the organic compound below. Which of the following statements about the above compound is correct? So we're looking for the IUPAC name of the above compound, right? So instead of looking at our options, let's just name it ourselves, and then we'll just pick the option that corresponds with the name that we have. So first things first, the longest carbon chain. So I can have 1, 2, 3, 4, 5. And then I can also go down and have 1, 2, 3, 4, 5. That is 5. And then if I start here, I also have 1, 2, 3, 4, 5. If I go straight, I have 5 again. If I go up, I have 5 again. It doesn't matter where you go, you're going to end up with 5 carbons. So we can conclude and say that we have 5 carbons in our longest chain. Now what we need is the functional group. We have a double bond right here. So that tells us that this is an alkene. We have to start numbering our carbons from the side closest to the functional group. So from the left hand side. So we're going to have 1, 2, 3, 4, 5. On the second carbon, we have a methyl. And then on the fourth carbon, we have 1 methyl and another methyl. So our name will be 2,4,4 dash tri, because we have 3 methyl pent-2-ene. This is our branches, and this is the number of carbons on our longest chain. This is where the functional group is, and this is how the name of an alkene is. So which option is that in 1.3? It seems like it is option C, 2,4,4 dash trimethyl pent-2-ene. So our answer to 1.3 is C. Our answer to 1.3 is C. Let's move to 1.4. 1.4. From the following options, choose one that best explains why catalysts are so extensively used in chemical reactions. I think we use them so extensively because they speed up our reaction. They lower the activation energy. So option A says that catalysts can be used to drive the equilibrium in the desired direction. And then B says catalysts decrease the reverse reaction. We know that not to be true. And then C says catalysts have no effect on the reverse reactions. And then option D, catalysts can cause the forward and reverse reactions to proceed at a faster rate. We know that for sure, the lower the activation energy. So for 1.4, our answer is D. We use catalysts mainly because they cause the forward and reverse reaction to proceed at a faster rate. Let's look at 1.5. 1.5 says, study the following graph and match label X from the following choices. So let's look at label X. Before we even look at our choices, label X is our activated complex. And that seems like option B, activated complex. So the answer to 1.5 is B. So let's go to 1.6. 1.6, it says that the equation below represents a chemical reaction at equilibrium in a closed container. Which of the following changes will increase the yield of HI in the above reaction? So let's go ahead and do some analysis. HI is our product, right? If we're looking at the forward reaction, and then the forward reaction is exothermic. We can see that the enthalpy change is less than 0. Let's look at option A. They're saying that increase in temperature. Can we increase the yield of HI by increasing the temperature? Let's find out. Increasing the temperature favors endothermic reaction. And if we're saying that the forward is exo, the reverse is endo, right? So if you increase in temperature, HI is actually going to decrease because the reverse reaction is going to be favored. But looking at option B, decrease in the temperature. If you decrease the temperature, exothermic reaction is favored. So the forward reaction will be favored, and that will lead to more HI. So before even looking at option C and D, we can see that our answer is option B, right? Option C and D are actually not correct because they talk about pressure, and we have the same number of moles on the reaction side, on the reactant side, and then on the product side. So whatever you do to pressure, it's not really going to affect the yield. It will only affect the rate. And then moving to 1.7, which of the following solutions, each of concentration 0.1 moles per decimeter cube, has the highest pH? Right. So the highest pH, we're looking for the solution that is the most basic. Will have the highest pH. And then the first solution is HNO3. HNO3, we know fully well that that is an acid, so it cannot be our answer. And then option B, NH4Cl is an acid salt, so it will have a pH that is less than 7, so that cannot be our answer. On the other hand, Na2CO3 is a base, so maybe that can be our answer if we don't have another stronger base. Option D is ethanoic acid. Obviously, that cannot be our answer. So for 1.7, the answer is actually C. That is the only basic solution that we have. Let's look at 1.8. 1.8 is saying a solution of ethanoic acid is titrated against a standard sodium hydroxide solution. Which one of the following indicators will be the most suitable for this titration? We have actually answered a very similar question. If you want to see the question I'm talking about, go to a playlist named Acids and Base. You're going to find the question right there. Ethanoic acid, it is a weak acid. So we have a weak acid plus sodium hydroxide, which is a strong base, So if you have a titration between a weak acid and a strong base, then the pH you will end up with will be greater than 7. Greater than 7. We're going to use indicator A, which is phenolphthalein. If you had a strong acid and a weak base, we would use methyl orange. Right. Moving to 1.9. So in 1.9, which of the following correctly gives the direction as well as the medium in which electrons move in a galvanic cell? Without even looking at our option, the electrons move from the anode to the cathode. And then which medium, how do they move? They move through what? They move through an external wire. So that is option B. So the answer to 1.9 is B. They move from the anode to the cathode through an external wire, not through the salt bridge. No. And 1.10, which of the following half reactions occurs at the cathode during the electrolysis of a solution of concentrated NaCl. At the cathode, there's deposition. Something is deposited at the cathode. So we know that by just saying that option A cannot be our answer and option C cannot be our answer. The only possible answers we have, which makes a bit of sense, is actually B and D. Can you please let me know in the comments which answer you're going with for 1.10?